This video is on leaving groups. The nature of the leaving group is very important in both SN1 and SN2 reactions because in both, a bond to the leaving group is broken in the rate determining step. So what do we need to look for in a leaving group? Well, the stability of the leaving group is super important. The more stable it is as a free anion, a higher rate the reaction will have. If you think about it for a moment, this is literally the argument for the stability of conjugate bases and acidity in general, right? The more stable the conjugate base, the more acidic the thing is. Well, here, the more stable the free anion of the leaving group is, the faster the reaction will go because the more willing it is to give up the electrophile. As we would expect, the halogens are relatively good leaving groups, and as halogen anion stability increases down a group, you would expect the rate of reaction to follow suit, as seen here. We also see that water is a very good leaving group, but you'll notice that you don't usually have a water bonded to carbon, you usually have an alcohol. So what this is telling us is you need to have acidic conditions to protonate that alcohol to make it a good leaving group. An alcohol by itself is a terrible leaving group, as hydroxide is unlikely to want to leave by itself. These structures at the bottom, the mesylate and tosylate, are the best leaving groups due to the resonance stability in the anions. However, once again, you can't just find mesylates and tosylates sitting around. You have to start with an alcohol and a mesyl or tosyl chloride, which you react with the alcohol to make the mesylate and tosylate, which then leave in your reaction.